Welcome back. In this video, we are going to solve a structural design problem that involves a simple beam design using the working stress method based on eStructural Design Taichi found on the App Store. Design a 10 inches by 20 inches reinforced concrete simple beam using working stress method with span of 20 feet. The beam carries a uniform load of 1,800 pounds per foot. Design criteria as follows: strength of concrete 3000 psi, main bars 3/4 inch diameter bar grade 40, stirrup bars 3/8 inch diameter bar grade 33. The beam carries a uniform load of 1,800 pounds per foot and a self-weight of 209 pounds per foot for 10 inches by 20 inches beam size, giving us a total load of 2,009 pounds per foot. Enumerate input parameters required. B3 for name of beam, 10 inches width of beam, 20 inches depth of beam, length of beam 20 feet, main bars 3/4 inch diameter bar grade 40, stirrup bars 3/8 inch diameter bar grade 33, strength of concrete 3000 psi, and total uniform load 2009 pounds per foot. Solve the balance section properties given Fc prime equals 3000 psi, Fs equals 20,000 psi. We get N equals 9.289, K equals 0.385, J equals 0.872, R equals 227. Proceed to solve for flexure and depth of beam. With a total load of 2009 pounds per foot and 20 feet beam length, the moment is 964,320 inch-pounds. The effective depth is 20.61 inches, and total beam depth is 23.11 inches. We provide 20 inches as beam depth, less than the balance depth. Therefore, we will proceed to doubly reinforced beam design. First, solve the moment capacity of the beam section given R equals 227, B equals 10, and D equals 17.5. We get M1 equals 695,187.5 inch-pounds. Then subtract M1 from total design moment to get the excess moment required, which is M2 equals 269,132.5 inch-pounds. The area of steel from M1 is 2.28 square inches, and M2 is 0.87 square inches, giving us the total area of steel of 3.15 square inches. The number of tension bars from a 3/4 inch diameter bar is 7.16. Use 8 pieces. For compression bars, we get Fs prime equals 17,607.4 psi less than 20,000 psi, and As prime equals 0.99 square inch. The number of bars from a 3/4 inch diameter bar is 3.85. Use 4 pieces. To test shear stress and bond stress, first solve for shear force, which equals to 20,090 pounds. Shear stress equals to 114.8 psi greater than 60.25 psi concrete capacity, which means stirrups are required. For bond stress, the total circumference of bars is 18.88. Bond stress is 69.73 psi less than 350.54 psi concrete capacity. The design shear stress is 115 psi and 60 psi for concrete capacity. The required additional stress capacity from steel is 55 psi. The maximum spacing for stirrup is 8 inches. The steel region is 58 inches. Steel capacity is 55 psi, and the initial spacing is 7.2 inches, less than maximum spacing. Use our case 3 computations given x equals 58. For group 1, set initial distance s equals 0. Web stress equals 55 psi. and spacing at 7.2 inches, say 2 inches. Use 1 at 2 inches from face of support. For group 2, the distance S equals 2 inches, web stress equals 53.1 psi, and spacing at 7.46 inches, say 4 inches. Use 1 at 4 inches. For group 3, the distance S is 6 inches. Web stress is 49.31 psi and spacing at 8.03 inches, say 6 inches. Use 1 at 6 inches. For group 4, the distance S is 12 inches. Web stress is 43.62 psi and spacing at 9.08 inches, greater than 8 inches maximum spacing. Therefore, rest at 8 inches on center. For 3/4 inch diameter main bars, use half-inch diameter stiffener bars. The design results for our problem are as follows. Fc prime equals 3000 psi. Fs equals 20,000 psi. Beam size is 10 inches by 20 inches by 20 feet. Main bars of grade 40. At support, top bars 8 pieces 3/4 inch diameter bar. Stiffener bars 2 pieces 1/2 inch diameter bar. Bottom bars 4 pieces 3/4 inch diameter bar. At center, top bars 4 pieces 3/4 inch diameter bar. Stiffener bars 2 pieces 1/2 inch diameter bar. Bottom bars 8 pieces 3/4 inch diameter bar. Stirrup 2 legs of grade 33, 3/8 inch diameter spacing, 1 at 2 inches, 1 at 4 inches, 1 at 6 inches, rest at 8 inches. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.